Let's take a look at that starter question. What's the opposite of 3/4? Opposite of 3/4. Let's not complicate the issue. Negative 3/4. That's it. Because if I said what's the opposite of 2, you'd say negative 2, right? If I said what's the opposite of negative 17, you'd say positive 17, right? So the opposite of 3/4 is negative 3/4. Okay, now, I could actually write it 3 different ways, and I think I mentioned this last week. Okay, we can write it on the top, we could write it out front, or I could write it on the bottom. What I could not do is do this. I couldn't say the opposite of 3 and the opposite of 4, because what would that be? I'd be right back where I started at 3/4. Okay? So please don't forget this. There are 3 ways to write a negative fraction. You can write the negative on the top, out front, or on the bottom. Where do we normally write it? Usually on the top. Second best would be out front. Okay? Usually the worst place to have a negative is in the denominator. It's hard enough to have denominators, let alone if they're ugly numbers, if they're negative, if they're radicals, and things like that. Okay? All right, so kind of put that in your back pocket for right now, and let's talk about functions for just a second. Okay? State the domain and range shown for this correspondence right here. So again, the domain are the set of x's. So I'm going to write down a 1, a 2, a 3, a 4, and a 5. That's the domain. And then I'm going to write down the range, 10, 20, 30, 40, 50. And then I'm going to map this to show the correspondence. So remember, we did some of this the other day. And the question here is this a function? And the answer is yes. Why? Why is this a function? Okay, Tony, say that again. All x's correspond to only one y value. That's exactly right. Each x corresponds to only one y. Okay? So if we added the point 4, 10 to it, so if I added 4, 10 up here, 4 was already in the domain. I don't need to rewrite it. 10 was already in the range. I don't need to rewrite it. But I do need to show this. I do need to map 4 to that point right there. Is it a function now? The answer there is no. Okay? What's the reason it's not a function? 4 has 2 y values. There's an x value that corresponds to 2 different y values. Okay? Now, here's the problem. This is why we care about functions. Okay? This is a nice linear pattern here. Imagine if x represented the hours you work and y represented your pay for that many hours. First of all, how much are you getting paid per hour? $10 an hour. Okay, that's a pretty decent job right now, right? Okay. Why would we care about this? Why is this a big deal if you go into work for 4 hours? Raymond? Okay. You can't be paid $10 and $40 an hour. They can't both happen at the same time. Okay, think about it from your perspective. Let's say one week you go in and you work 4 hours and you get paid $40. You walk out and you say, sweet, I got $40. Let's say you go back the next week and you work 4 hours and you walk out with $10. What are you thinking? Bad words. Thank you very much for not saying that. Okay, that's no fun, is it? You don't want to wonder whether what's going to happen when you go and work for 4 hours. You want a definite answer. You want to know that when you go in and work 4 hours, you get $40 every single time because you make $10 an hour. Okay? So we can actually see that there's a problem here if we graph this. So if I were to put these points over here, let's say this is in ones, and this is in tens. And if I put these points on here, I get a graph that looks something like this. So the more you work, the more hours, the more you get paid. Goes just like this. Except for if we put this ugly point on here. If I put that one on there right there, okay? Let me make that one a little bit bigger. We don't like this. And again, the reason we don't like this if this were a pay situation is sometimes you go in and you get paid $40, and sometimes you get paid $10, and we don't like that. Okay, and graphically we can describe this. These 2 points are on the same vertical line. So this was the problem, and this is the reason it's no longer a function. Because for this x value, I've got 2 y values. They're stacked right on top of each other, and we don't like that. Okay? And we can describe that using a particular test on a graph. Does anybody know what it is? It's called the vertical line test. Okay? So the vertical line test. So if you look at a graph, which we'll be doing a lot of, you can look at it and you can tell whether or not it's a function. Just draw a bunch of vertical lines. Would any vertical line only intersect it once? If it does, this is a big yes on this one. This is a big fat no. And what about this one right here? This is in pieces. This probably came from a piecewise function. Is this one a yes or a no? Noah? It's a no. Tell me where the problem is. Tell me when to stop. Okay, right here. This is the problem. And that problem only has to exist once. If there is even one single x that corresponds to 2 y's, we do not have a function. Notice that this part passes the vertical line test, even right here. Notice the closed circle and the open circle. Right here, neither one of those has a point. All of these other places it passes the vertical line test except for right here. And because of that, that answer is a no. Okay? So in the last section, we were talking about finding domains, and we had to find them algebraically. So we had to look at some stuff like this. We had to look at this and say, well, what part of this, or what number can't I plug in? And what number does not exist in the domain here? 6. So this would be all reals except for 6, because 6 would make the denominator equal to 0. Okay? These are a little bit more difficult because we want this right here to be greater than or equal to 0. So I'd have to move that over, and my domain on this one, again, it's better to state what the domain is than what it's not, unless we're just throwing out 1 or 2 numbers. Okay? So this is going to be x's that are greater than 10. That would be the domain there. Okay? But the easiest way to find the domain of a function is not by doing it algebraically if we've already got a graph. Now remember, domain, range, they go alphabetically, x, y. So the domain are the x's, the range are the y's. So the easiest way to do this is if you have a graph, we'll use what we call the squish technique. If I take this graph and I squish everything onto the x-axis, like this, what part of the x-axis would be covered? Okay? So if we squish it onto the x-axis, that's going to find the domain. And if I squish it onto the y-axis, that's going to find the range. Well, let's focus on finding the domain for this particular function right now. What part of the x-axis is covered? Where do we get answers? Start way down here at negative infinity. Where do they start? At negative 2. So the domain is going to start at negative 2. We'll put a comma. Where does it stop? Positive 4. Okay? Round or square around the negative 2? It's going to be round because that point is not included. Okay? What about the 4? Square bracket there. Okay? Let's switch over and let's do the range. So to do the range, we're going to squish this onto the y-axis. So we're going to push everything over here. Okay? And these are kind of repeated over there. And then again, start at the lowest point, or way down here at negative infinity. Where do we start getting answers? Negative 3. So this is going to be from negative 3, comma, where do we stop? Stop at positive 1, don't we? Okay, because we get answers from here all the way up to right there. Is that okay? Any questions there? Yeah. Mm-hmm. The negative 2? No, because, okay, I see what you're saying. So as far as the range goes, so this point doesn't exist, so we pushed it over here. It doesn't cover that part, okay? But this point right here does. Does that make sense? If we push this side over, it covers everything from here to here. This just kind of duplicates most of it. It's covered from one side but not the other. But as long as it's covered from one, we're totally okay there. Good question. Does that make sense? Okay. Next question. Not done here. So what do we have to figure out? Round or square, right? Round or square. What about the 1? Definitely square. No questions about that, right? What about the -3? Round or square? Let's vote. Round? Square? Oh, you square people. You're right. Okay, it's square. Can somebody who raised their hand to tell us it's square, tell us why it needs to be square? Why does it need to be square? Raymond. Okay. It actually touches at -3. We have a y value out of this that equals -3. This point right here is 0, -3, so it actually has a point there. This one right here in terms of x, okay, that -2 wasn't there. That's why that's a round bracket, okay? All right, if you would kind of read ahead, maybe take a look at what the homework is, that would be great. We'll pick up right there tomorrow.